Here are the notes for 8.2b, the Pythagorean theorem. So firstly, we have to get some vocabulary, and a theorem is a theory that is true until proven wrong. So Pythagorean theorem was proven true a long time ago, and it's never been proved wrong. And then we have to get, this is all about a right angle triangle. So we're going to look at the legs and the hypotenuse of a right angle triangle. So a right angle triangle, it's really important that we have our right angle, and it could be written or drawn, in any direction as long as there is a right angle. The legs are the two lines or sides that come together to make the right angle. So this is leg, and we'll just call this A leg and B leg. So here we have, this is a leg because it's coming towards the right angle. This is another leg because it is forming the right angle. And the A and the B don't matter where you put it. Then there's the hypotenuse. The hypotenuse is always directly opposite the right angle sign. We'll call that C. That's the hypotenuse. And notice that it's longer. So the hypotenuse is always the longest side. I'm going to give it the label C. So there's the notes, hypotenuse and legs. And then the theorem is a squared plus b squared equals c squared. I'm going to look at how that works over here. Here's a triangle, and it's a right angled triangle. We have one side length is 3, one side length is 4. And we're going to look at those as if we put a square here. So we have a square with a side length of 3, and we know the area of the square is going to be 3 times 3, so 9 centimeters squared is the area of this square. And here is our square of side length 4. And 4 times 4 gives our area, which is going to be 16 centimeters squared. And then our hypotenuse is going to be an odd number. It doesn't follow exactly all of the squares. If I cut it out exactly, it actually ends up being a square with an area of 25 centimeters squared. So that means the side length is going to be 5. But the theorem is what we need to work out. And we can notice that 9, which is this square, plus 16, which is this square, equals 25. 9 plus 16 is going to equal this square. So rather than working in squares on each side, we can just take a number squared plus another leg squared is going to equal the hypotenuse squared, which just so happens to be 5. 9 plus 16 equals 25, or 3 squared plus 4 squared equals 5 squared. So the side lengths will be 3, 4, and 5. And that's how we get the formula a squared plus b squared equals c squared. So up here we had, this is A, this is B, and this is C. And we usually talk about the hypotenuse being C, and it doesn't matter where the A or the B are. I could have done that one as B and that one as A.